So let's look at primary and secondary in protection. What does that mean? Remember, our protection relays are connected to the system via current transformer and voltage transformers. That means we have current values in the line or in the cable, and this value is called the primary value of the current. And of course, we also have a voltage, for instance, between the conductor and ground, that is called the primary voltage. As discussed, we cannot connect that directly to our devices. We use current and voltage transformer. That means we also have a current which flows into the protection device, and that current is called the secondary current. And we also have a voltage which is seen or measured by the protection device, that is called the secondary voltage. That means if we talk about electrical quantities, we must distinguish between primary side and secondary side. But it also means if we talk about settings, we can talk about settings in terms of primary values or settings in terms of secondary values. Just to illustrate that a little bit, I want to come back to the current transformers. You see here again a picture of a current transformer for distribution level. In this case, it has a current transformer ratio of 600 amp to 1 amp. That means the primary rated current is 600 amps. On the secondary side, we have 1 amp, and that is what goes into the protection relays. And in protection, traditionally, we have 2 standard nominal currents on the secondary side, and that is either 1 amp or 5 amp for this conventional type of transformers. There are other types also coming up, but still the big majority has these current transformers. And 1 amp and 5 amp are pretty high currents. Imagine these values are the current values for rated current, normal operation. And if you have a short circuit, you have, of course, much higher currents. And that is the reason if you look into our protection relays, that is a terminal block where the current is connected. Actually, you see 2 things. You see the terminal blocks where you connect the current are much bigger than the other terminal blocks. And the reason behind that is that they must be able to carry the high current. Nominal current 5 amp. Normally the devices have to be tested to withstand 100 amps, 100 times nominal current for 1 second. And that would mean 500 amps for 1 second. And you can imagine for that you need bigger screws, and of course you also need sufficient cross-section. What you also see here is you have phase 1, 2, 3, and you have the 4th pair of inputs for the Holmgreen connection or for a sensitive, for a core balance CT to connect it. That was the current transformer. On the voltage transformer side, we have typically, here's an example, 110 kilovolt divided by square root of 3 to 100 volt divided by square root of 3. Where does the square root of 3 come from? If you have a 100 kilovolt line, the 100 kilovolt is the voltage between the 2 phases. The voltage transformers are normally connected from phase to earth. That means the voltage they see in normal operation is in this case 110 kV divided by square root of 3. Same applies to the secondary side. It is normally something around 100 volt, also there divided by square root of 3. This voltage is also not quite standardized. 100 volt is a thing you often find, but you also may have 110 or even 125 volt. So that was the example, just the definition, what primary and secondary is. What does that now mean for protection? In all states where you calculate settings or where you deal with settings, it must be clear, are you talking about primary values or secondary values of setting? Normally, you start the calculation of setting values from a network calculation. You have to calculate load flow, you have to calculate short circuits, and the values you see there are primary values. Relay settings, as the relay measures behind current transformer and voltage transformer, are traditionally often treated as secondary values. That means on this way, from calculation of settings to bringing the settings into the relay, you must somewhere do the conversion from primary to secondary. With digital relays, that has become, of course, much easier, as a PC program can be used using the primary values. That means that can do the conversion. So part of this conversion can be assigned to a program or even to the relay itself. But nevertheless, you must be careful. And there are 2 points where, according to my experience, often problems occur. One thing is, if you talk about a setting of an overcurrent relay, it's very easy to see, is it a primary value or a setting or a secondary setting value? If somebody tells you the setting is 1000 amp, you know, okay, 1000 amp looks like a primary value. If he says the setting is 1.5 amps, you know it's a secondary value. That's easy. But also in distance protection, where the setting values are impedances, you have to do the conversion, taking into account the ratio of the voltage transformer and of the current transformer. And then it's not visible if somebody says the setting value is 5 ohms. The 5 ohms can be a primary value or a secondary value. It must be clear what it is. And I had a lot of occurrences where something went wrong in the protection, and the end of the story was that people mixed up between primary and secondary values. It is basically trivial, but sometimes problems happen at that point. And the other thing, the other location where you have to be careful is the question, what is going to happen if a relay is in operation and somebody has the idea to change the current transformer? That means to install a current transformer with a different ratio. That can happen because something has to be replaced or the substation is extended or whatever. Then you must make up your mind, because in this case, you have to change either the primary setting value or the secondary setting value, because they are connected with the ratio of the current transformer. And if you change that ratio, at least one of them has to change. And it must be very clear that you decide which one has to be changed and which one can remain constant. That was a short chapter about primary and secondary. And in the next chapter, we will start to build up a protection scheme for a feeder or a transformer feeder.